There's another new FPGA gaming system on the market, and this one is a very polished implementation of the MiSTer project. This is the SuperStation One, and today we're going to tear it down and see what's inside. As you know, I've covered a lot of MiSTer hardware on this channel, including one of Retro Remake's other products, the MiSTer Pi. But this device is different. The SuperStation One is an all-in-one MiSTer console. Even though it looks like a PlayStation, it's a MiSTer under the hood, so it runs all the standard cores that you would expect. And it retails for around $225, which for what you get is a fantastic deal. Looking closer at the device, it's obvious that Retro Remake's design was inspired by the PS1. The shell is injection molded, and that gives it a very different feel from the other MiSTers on the market. On top, you have the Retro Remake logo, a power button on the left, and a menu button on the right. Underneath, there's an expansion port for the upcoming SuperDock, which we'll talk about more shortly. Up front, you'll find ports for two PS1 controllers and memory cards. And between them, you'll find a USB port with a microSD card underneath it. On the right side, we can pull down the flap and get access to RCA audio jacks, as well as component video. There's also a 4-position dip switch that controls the analog video output configuration. Looking at the back, we have an Ethernet port, a 3.5mm audio jack, a VGA connector, a 10-pin mini DIN connector, HDMI output, 2 standard USB ports, and a USB-C port for powering the console. Finally, on the left side, there are 3 more flaps hiding composite video output, an RCA jack for a PlayStation gun controller, and S-Video. To open it up, we have 3 visible screws on the bottom. And we have to remove the rubber feet to get access to 4 more screws. Once those are out, the top shell lifts right off to reveal the main board. The board itself is secured to the bottom shell with 2 more screws. The expansion port also has 2 screws and a ribbon cable, and the 2 front snack ports each have 2 screws and their own ribbon cables. There's also this wire that needs to be unplugged. We'll talk about what that's for in a bit. With everything disconnected, the board lifts right out. And if we remove the heatsink from the center of the board, we'll uncover the FPGA underneath. Okay, so here's the main board. Mine is a white PCB with revision number 1.2.3. Now, Bob over at Retro RGB got one of the earlier units, and you can see in his review that his unit was revision 1.2.2. When I was looking at Bob's photos, I realized that there are some notable differences between these revisions. For example, the RTC module is a daughter board on Bob's unit, but is built directly into the main board on mine. The Wi-Fi antenna also changed from a detachable connector to a curved piece of metal fixed in place. There are also various layout updates, but other than some chips getting moved around, I don't see any major design changes. It's no secret that the design has changed even up to the last minute, so much so that even the product renders on the website are outdated. But one thing that hasn't changed is the brain of the SuperStation One, a Cyclone 5 FPGA. As you can see, the part number on my chip indicates that it's the SX variant of the Cyclone. It's mostly the same as other MiSTer devices. It's still an SoC with an ARM Cortex CPU alongside the FPGA fabric. It also has the standard 110,000 logic elements that we expect to see in a MiSTer. But since this is the SX variant, It also has 6 high-speed bus transceivers that are capable of over 3 gigabits per second each. These transceivers can enable things like PCI Express and Gigabit Ethernet directly from the FPGA fabric, though they're likely not being used in this case. It's also interesting to note that this chip is rated for an industrial temperature profile, which means it can withstand a broader temperature range. The Cyclone 5 SX is the same chip used in the Mr. Pi, but it does differ slightly from the FPGA that you'll find in the DE10 Nano and the Mr. Multisystem 2. But it doesn't really make much of a difference. All these boards run Mr. cores just fine. As shipped, the SuperStation One relies on this large heatsink for passive cooling. Now, people have different opinions on this, but I run most of my Mr. setups with passive cooling and I've never really had an overheating problem. That said, a fan might just give you more peace of mind. And to accommodate that, there is a fan power header on the board with a JST connector and a selectable 5V or 3V jumper. You can either add your own fan, or Retro Remake also sells an official active cooling add-on, though at the time of this recording, it's not yet for sale. For memory usable by the cores, there are 2 64MB SDRAM chips from e-tron Tech. Together, they provide 128 megabytes of SDRAM, and that lets you run the more demanding cores like PS1, Saturn, and Nintendo 64. Now, these are the same chips that Retro Remake uses on their plug-in SDRAM modules for Cyclone dev boards. I tested these chips in a previous video and found that they were stable and error-free at 144 MHz. However, these chips are now soldered directly to the PCB, so it's worth testing them again. I put the SS1 through the memory tester, and the results were pretty good. The test ran for about 2 hours, and the SDRAM stabilized at 150 MHz, which is well above the minimum that Mr. requires. Also on the board are 2 Micron DDR3 chips, providing 1 GB of memory to the hard processor. These are 933 MHz chips with a CAS latency rating of CL13. In fact, they're the same DDR3 chips used in the Mr. Pi. I've mentioned in the past that the official DE10 Nano uses ISSI chips rated at CL9, but these higher latency chips all seem to work just fine. You may have noticed that the SuperStation One has a lot of analog video output options. In fact, you might even say that this is one of the biggest selling points. Now, I spent quite a bit of time digging into the analog video design, and I have to say, this is one of the most sophisticated analog video implementations I've come across. Whenever I put together these deep dive videos, I always question how in-depth I should go. I really considered holding back on this topic, but I know many of you enjoy these videos because of the technical depth. So here's how the SuperStation One's analog video subsystem works. First, you need to understand that the Cyclone 5, like most FPGAs, only outputs digital signals. So in order to get analog video out of a Mr., you need some sort of digital to analog converter. There's actually several ways you can convert a digital signal to an analog one. And one of the more common routes with Mr. accessories is to use what's called an R2R resistor ladder. This basically allows you to combine the various bits of red, green, and blue color data into an analog waveform. This technique is used by the earlier versions of the analog I/O boards because it's cheap and pretty easy to implement. But more recently, some boards, such as the Mr. Add-on's I/O Analog Pro, have started using dedicated DAC chips, such as this ADV7125 from Analog Devices. And this is the same chip that's used by the SuperStation One. The ADV7125 is a triple 8-bit DAC, so the analog video signal is being generated from a full 8 bits of color data from each channel. Now, if you're just driving a single analog RGB output, such as a VGA monitor, you can go ahead and wire the chip up to your output circuit. But the SuperStation One doesn't stop there. Instead, it routes the analog RGB output from the DAC into an LMH6722 op-amp, which functions as a buffer, and that lets you fan out the signal into multiple outputs. In fact, the SS1 feeds the RGB signal from this chip into 4 different places. 3 of these are external ports. There's the VGA port, the RGB pins on the 10-pin mini DIN connector, and the RCA ports on the side labeled RGB. In addition to that, the SuperStation One can also output composite and S-video, and it can do this in one of 2 ways. First, the FPGA can actually generate the necessary luma, chroma, and composite video signals, so you could choose to use the FPGA-generated video. But there's also another option, and that's the 4th place the RGB signal outputs to, a Sony CXA2075M. This chip is an analog video encoder that turns the RGB signals into composite, luma, and chroma. Now, to switch between these 2 options, you need to toggle dip switch number 3 here on the side. This switch controls 2 separate analog switches on the main board. First, there's this dual port switch by Texas Instruments called the TS5A23157. This chip is dedicated to switching the composite video signal to both the CVBS jack as well as the composite video pin on the 10-pin mini DIN port. The second switch it controls is this one here, another Texas Instruments chip called the TS3A27518. This chip switches the luma and chroma signals that feed S-video. By default, when dip switch number 3 is in its down position, it's configured to pass the Sony chip's video signal through both of those switches, which is why it's labeled as external on the main board. When you flip it up, it pulls the input pins on those Texas Instrument switches to ground, and that changes the signal path so the composite, luma, and chroma signals all come from the FPGA. Now, before any of these analog video signals can be used, they all run through a set of Texas Instruments THS7374 analog video amplifiers. There are 3 of these on board. 2 of them are on the bottom near the composite switch, and there's also one on top. So the result of all this is that Retro Remake jumped through a lot of hoops in order to incorporate this external Sony analog encoder chip. Like I mentioned, the FPGA can generate these signals itself, so none of this is really necessary if you just want to provide composite and S-video output. But since the FPGA is purely digital, the signals it creates are all quantized waveforms. So you're definitely going to get a better analog video signal from this Sony chip. Digital video output is a different and much more simplified story. The SuperStation One uses the same HDMI transmitter chip used by the other MiSTer implementations, the ADV7513 by Analog Devices. This chip natively takes the digital RGB signal from the FPGA and encodes it for HDMI output. This chip officially supports up to a 1080p resolution, but many MiSTer users often push the pixel clock higher to get resolutions like 1440p or 1536p. For audio, there's a Texas Instruments PCM5102 digital to analog converter. This DAC takes the digital audio signal coming out of the FPGA and I2S and converts it to a high-fidelity analog audio signal. This analog audio signal is then sent to an SGM8909 stereo audio line driver. This chip's job is to clean up the signal and drive it at line level to whatever you plug into the SuperStation's analog audio ports. For HDMI audio, the signal stays digital. The FPGA sends I2S audio directly to the ADV7513, which packs it into the HDMI stream right alongside the video. For USB, the SuperStation One uses an FE 2.1 as the USB 2.0 hub controller chip. This chip supports up to 7 downstream USB ports, and it connects upstream to the USB PHY interface on the Cyclone 5. Two of these ports fan out to the rear of the device where you can connect peripherals such as a USB hard drive or a keyboard dongle. An additional port is available up front, and that's convenient for USB controllers. In addition to that, there's also a USB port fanned out to the dock connector. It's no secret that the SuperDock will contain an additional 4 USB ports. So in order to do that, it'll need to include its own USB hub controller that uplinks to the FE 2.1 through the connector. One of the remaining USB ports is taken up by this device. This is a combination Wi-Fi and Bluetooth module called the 6221E-UUC. This module contains both Wi-Fi and Bluetooth, both uplinked to the FE 2.1 through a single internal USB port. It runs a Realtek RTL8821 chipset, and that provides a dual-band Wi-Fi on 2.4 and 5 GHz, 802.11 AC, and Bluetooth 4.2 with BLE support. This curved piece of metal here in the back corner is the Wi-Fi and Bluetooth antenna. You can see here that it's soldered directly to the PCB in this revision of the SuperStation One mainboard. For wired networking, the Ethernet port is connected to a KSZ9031. This is a gigabit Ethernet interface from Microchip, and it's the same Ethernet chip used in the Mr. Pi as well as the DE10 Nano. A lot of people still like to connect their Misters to a physical Ethernet cable, so it's great to see that Retro Remake kept this capability in the box. If you've seen some of my previous Mister content, then you'll know that I'm a pretty big fan of the NFC game loading project called Zaparoo. The SuperStation One has built-in support for Zaparoo by embedding an NFC controller chip called the FSVP532. This chip is basically a clone of NXP's PN532, which is a common controller chip used in many NFC readers. Now, it would be nice to have an actual NXP chip in here, but real PN532s are quite expensive, and this chip is half the cost. Right next to it is a CH340N USB to UART bridge. This chip takes the 532's UART output and puts it on the USB bus, and that presents the NFC reader to the Mister as a standard USB device on the USB hub chip. Now, you'll recall from earlier that we unplugged this wire from the mainboard during disassembly. This is the NFC coil, which is mounted into the front of the shell. So in theory, you should be able to just tap your NFC token here, and the SuperStation One should read it. However, there's a major flaw here, which makes the NFC reader unusable for most Mister users. You see, like many other Zaparoo users, I have a collection of NFC cards with really cool stickers made by Aerial Aces. But unfortunately, this coil is too small for these cards. It works fine when scanning smaller button-style NFC tokens, but I think it's fair to say that the majority of Mister users are using cards. So based on the recommendation of another SuperStation One user, I purchased this larger coil from DigiKey. It does require you to solder a connector to it, so I did that and found a spot for it on the top of the shell. NFC cards work fine with this larger coil, but Retro Remake really should have just included one in the system. Like the Mr. Pi, the SuperStation One is also powered through a USB-C connector, leveraging the USB Power Delivery Protocol. To do the PD negotiation, there's a legendary technology LDR6328. This is the same chip that Retro Remake used in the Mr. Pi. This chip supports up to version 3.0 of the USB PD protocol, which means it could potentially negotiate up to 20 volts for VBus. Now, on the Mr. Pi, that chip was configured to negotiate up to 12 volts, and that's fine. But that does mean the buck converter that pulls that VBus signal down to 5 volts is working harder than it needs to, and thus generating more heat than necessary. So I was pleased to see that for the SuperStation One, Retro Remake updated the design and capped the maximum negotiated voltage at 9 volts. Now, I'm not going to do any thermal testing on the buck converters this time, but that main buck converter for VBus should definitely be running cooler in the SuperStation One. The two PlayStation ports on the front are both SNAC adapters, which stands for Serial Native Accessory Converter. This is an approach used by the MiSTer to connect native console accessories such as original controllers to the FPGA. This not only allows for a more authentic playing experience, but it also leverages the native controller protocol of the console you're playing, and that brings the input latency down to 0. I've gone more in depth on this in a previous video, so be sure to check that out if you want to know more about how SNAC is different than USB controllers. And at the end of the day, this means that these PlayStation controller ports will only work with the PlayStation Core. You can't use them to browse the menu or select a game. Now, if you've been around the MiSTer for a while, then this is something you're already used to. But for new users, this is probably a bit confusing. Looking closer at these ports, you can see that the controller port PCB is mostly just a pin mapping between the controller and memory card pins. This is because the PlayStation controller and standard PlayStation memory cards all operate on lower 3-volt logic levels, so they can be driven directly from the FPGA signaling without any concerns. Now, these SNAC ports can also work with other accessories such as the Namco gun con. In addition to using the PS1 port, these guns require an additional RCA connection in order to read the sync signal that's being sent to the TV. And that's why the SuperStation One has this gun controller port here on the side. This is all great, but noticeably missing from the SNAC setup is a standard USB 3.0 style user port. This means that you can't use SNAC adapters for any consoles except for the PlayStation. Now, it does look like this is coming in the SuperDock, so you will have this capability at some point, but for now, you're stuck with USB controllers for every other console. Now, if you're a core developer, there's good news. You should be able to develop and debug your MiSTer cores just fine on the SuperStation One. There are a couple of things to be aware of though. First, there's no USB programming support built in. Instead, you'll need to connect a USB blaster to the 10-pin JTAG header. The other thing to be aware of is that there is a UART port on board, and it's available by connecting to this 4-pin header. In order to use this, you'll need a USB to UART adapter, such as one of these FTDI breakout boards. This is another thing that'll be improved with the SuperDock. It'll contain a USB-C UART port, so you can just plug it directly into your computer for debugging. Speaking of headers, you'll notice that the LTC connector, which you would normally find on a DE10 Nano and MiSTer Pi, is missing. Now, the only thing that header was really ever used for in the MiSTer was the real-time clock module. Instead, you'll find the real-time clock embedded on the main board, and for that, it uses this MCP 79410 RTC chip, which communicates with the MiSTer over I2C. And on the other side, you'll notice this empty battery compartment. The SuperStation One doesn't ship with a battery, so if you want to use the real-time clock, you'll need to add in a CR1220. Once in, that'll provide power to the real-time clock chip when the SuperStation is unplugged. There's a lot to love about the SuperStation One. For one thing, it looks and feels like a console. This is certainly a device I don't mind having in my living room. We often hear how MiSTer builds tend to look like science experiments, and that's definitely not the case here. And with the coming addition of console mode, it'll be even more suitable for the whole family to pick up a controller and just start playing. That said, there are definitely some areas of improvement. First, it's cool that there are so many analog outputs, but it really does feel like Retro Remake overdid it. The price point is great, but I wonder how much further it could have been driven down if it didn't include all the analog ports and that Sony analog video encoder. Don't get me wrong, for geeks like myself, this is fantastic. But if you're buying a SuperStation One to just put on your TV with HDMI and play classic games, a lot of these really cool analog video features probably won't be used. There probably could have been an opportunity for a less expensive digital video only version, similar to what Heber did with the MiSTer Multisystem 2. Another area of improvement is the NFC coil. The coil it comes with is just too small for anything except buttons and NFC stickers. Like many in the Zaparoo community, I've enjoyed using these really cool NFC cards, but unfortunately they just don't work with the coil it comes with. Lastly, I was a bit surprised to see that there's no USB-based snack interface. Yes, it's very cool that the PlayStation snack is built in, but the PlayStation controllers only work with the PlayStation Core. That said, this is one area that the upcoming SuperDock will resolve, and I'm looking forward to digging into that accessory when it ships. Overall though, I have to say the engineering on this board is rather impressive. You can tell that the team really wanted to squeeze the best analog video experience possible out of this device, and that's pretty cool. But I'll quote my friend Bob and say at the end of the day, the SuperStation One is just a mister. And honestly, that's the best compliment you can give it. If you want a plug-and-play mister without the DIY, especially if you're a PS1 fan or a CRT and analog video enthusiast, then this is an easy recommendation. It's really hard to argue with what you get for the price. If you enjoyed this deep dive, please subscribe to the channel and consider supporting my work through Patreon. It really does go a long way towards helping me make these videos. Alright, that's all I have for today, so I'll see you next time. But, as always, until then, go make something cool.